I think so.
Good. Let's start.
Okay. Okay. Perfect.
Hello.
So thank you so much for inviting me, Andy. I guess you were starting. Sorry.
Oh, yeah, well, it's fine. I just wanted to say hello and welcome everybody. Good morning, good afternoon, good evening, wherever you're joining from. And yeah, very quickly, I'd like to introduce our speaker, Leslie McIntosh, who's the director of the Center for Biomedical Informatics at Washington University in St. Louis. And you and your team have been implementing the recommendations for electronic health records. And we're really looking forward to your presentations and telling us how you went about to implement them and any issues that you or design decisions you discovered on the way there. We will be recording the webinar, and we hope to be able to make it available afterwards. If you've got any questions, we'll keep all the attendees muted. If you've got any question, there is a questions box in the bottom right corner of your GoToMeeting interface. So if you've got any questions at any point in time, please type them in. We'll collect them over the webinar, and then I'll read them out at the end of the presentation so we can discuss them. Okay, and that I guess, and if you've got any other messages, you can just contact me via the chat box. And with that, I guess I'll hand over to you, Leslie.
All right.
Yeah,
Thank you so much, Andy, for having us and inviting us. I just want to give my one caveat that Andy knows, and that is I am suffering a bit from a cold. So if you cannot understand me, please put something in the chat so that he can read that out. So as he mentioned, I'm Leslie McIntosh, and I direct the Center for Biomedical Informatics at Washington University in St. Louis in the United States. And being involved in the RDA and then being involved with this data citation working group, it gave us an opportunity to explore the recommendations within our own environment. So I want to talk first about our environment so that you can understand a little bit better about why this was important for me and us. And before I move from this slide, I just want to make sure that everyone knows that I do not do this by myself by any stretch. I have the other people listed here, Cynthia, Dan, Snehill, Connie, and Brian, who do a phenomenal job and really do all of the heavy lifting on this. So I really want to thank them for their work. So let's talk a little bit about the background and my environment. So we work with a system I've named Biomedical Data as a Service. So what this is we have a repository of biomedical data, which for the most part has all of the electronic health record data housed in it, along with some other data. So this would be when a patient comes into a hospital, the patient gets from normal care, diagnoses, procedures, labs, medications, any sort of allergies. Those things are recorded in our electronic health record, and then that's recorded operationally, but we take the data and move it into a repository so that we can do research on the data. Now, there are different ways of accessing the data. One is through the data broker as depicted at the top, and another is through the I2B2 app. It is through an application such as I2B2. So what happens is researchers may have a question. For instance, they want to understand how many smokers that we have within our hospital and how that perhaps has changed over the last 5 years. So they will contact us and determine how to get access to the data. At this time, there are a couple of options. One is through a user interface that they can access, and another is through using a person, a data broker, that is the liaison between the researchers and the data repository. And this person has knowledge of the data that are in the repository and also some of the scientific background, but really understands more of the data. I want to be clear that the data broker is not a developer and is also not solely a clinician, and this comes into play a little bit later and why we implemented some things. Traditionally, researchers can look at an application, but the way that our clinical researchers look at data tends to be from the perspective of the clinician, which is one patient at a time. This is why a data broker becomes very important, because data brokers understand how to look at the data in aggregate, and you pose questions a little bit differently depending on what perspective that you come from. So that's just a little bit of our biomedical data as a service. What part of the goal of implementing these recommendations or attempting to implement them has to do with wanting to move the responsibility of reproducibility from the biomedical researcher in and incorporate it into the biomedical pipeline. So from my research perspective, I'm trying to make our work more reproducible. And what I've noticed is a lot of the recommendations have put a lot of emphasis on the researcher, particularly when it comes to analytics. So using things like R Markdown, if you're using R for analytics, and having the researcher, who really, in my world, is a clinician who is doing research, that puts a lot of responsibility on them to then also understand more tools, and it takes time away from them doing their science. So part of the motivation here is to see what we as biomedical informaticians can incorporate within our systems so that we can give them, the researchers, information without having them learn a completely new domain. So with that background, there was an RDA MacArthur grant that came out in the US that was looking for people who could implement RDA recommendations in practice, and that's where we wrote a grant with using the RDA data citation recommendations. So the goal of our grant was to implement the data citation working group recommendations to our local Washington University I2B2. That would be the UI, the user interface that we had in order to access the data, to engage other I2B2 communities. For those of you who are not familiar with I2B2, it is widely adopted. It's a widely adopted application that sits on top of a EHR type biomedical repository. And then we wanted to be able to contribute the source code back to the I2B2 community. So as all things are, what you set out to do and then what you do are sometimes a little bit different. And that's what happened with this. So we decided to take these four approaches, or this approach. One is we wanted to assess our center's data infrastructure. The Center for Biomedical Informatics within Washington University. We wanted to assess it. Then we wanted to conduct a gap analysis of our infrastructure against the RDA data citation recommendations, define our local requirements, and then define and evaluate our approach. So let me walk through that a little bit more in detail. So here is an overview of our infrastructure. It's really kind of expanding on that one little repository I showed you before. We have an identified data repository. This is very important to note when you're dealing with biomedical data, in that we have some data repositories that contain data that could identify a person, and there are certain laws that we must comply with to hide this information, even though we can use it for research purposes. So this could be the names of the individuals, the phone numbers, it could be the addresses in the United States, the social security number, so the personal identifier given by the government. Those items would be in an identified data repository, including dates of birth and specific dates of events. We also have transformed data in other repositories that are not that do not have identifiable data. So if you will look where the dashed line is on the I2B2 application, what we had originally planned to do is actually make these changes at the I2B2 application, but as you will see, that changed a little bit as we went along. So after assessing just what is our infrastructure, we looked at a gap analysis of items within our infrastructure, and we mapped that against certain RDA data citation recommendations. So the data versioning, the data timestamp, the query stored, whether there was a query timestamp available, etc., as you can see. And as you can see on some of these, they did exist already by default, such as the data versioning and the data timestamp in our identified data repository. However, there were other things that were missing. So we really had to look at where we were going to start in our process and where we were going to implement changes based upon this. So our internal implementation requirements were that we needed to ensure that this could be scalable, meaning we were testing this only at our institution, and we really wanted to make sure that it could be implemented at other institutions. Because we used Postgres as our database, we needed to ensure that it would be available for Postgres. Obviously, this precludes any implementation into Oracle or another type of database, although we'd be very excited to see if someone tried to implement what we did and take that to another database. We needed it to be in an actively supportive environment. That really talks to the scalability of this, because if we made changes that had to be maintained locally, then the long-term sustainability would be hindered. It had to be easy to maintain and easy for the data brokers to use. This is where I want to go back to. We wanted to make sure that whatever we implemented, we would not have to call on a developer or some other technical, some other person who has access to the database or the repository from a technical standpoint to access it. We needed these data brokers who were the liaisons to be able to easily access this, to reduce the bottleneck. So what were the data citation working group recommendations that we were looking at? In the paper that we will give you, there's actually 14 recommendations. I'm not sure why in our paper we only put 11, but regardless, these are the ones that we decided we could attempt to implement, which was the data versioning, to apply versioning to ensure the retrieval of earlier states of data sets, the time stamping to ensure that operations on data are time stamped, the query stores so that we could select the data and the associated metadata, along with the store query, which also talks to the metadata, the query time stamping that assigns a timestamp to the query based upon the last update to the entire database, or the last update to the selection of data affected by the query. Implementing a query PID, a persistent identifier, and that becomes very important in trying to use the PID to identify the previous query. And then the citation, which has a couple of important characteristics, one being for the data brokers so that we will know what query has been used, but also so that we can get academic credit for people using our systems, which is very important for the sustainability of our infrastructure. So let's look at the implementation, or I should pause for a minute and see if there were any questions that I can't see, but maybe Andy, were there any questions that came up that I should answer? Okay, as I'm...
No questions at the time being, no.
Okay, perfect, thank you. So let's look at the implementation. This first one is data versioning and time stamping. Excuse me for all of my coughing. Give me just a moment to get a little bit of water. So we wanted to evaluate the existing versioning and timestamping methods in the identified data repository. As mentioned previously, what we ended up deciding to do is, instead of using the application, the I2V2 application, we decided to move up the river just a little bit and go into the identified data repository to make our changes so that it would affect everything upstream. So in that, I was very fortunate to have the team that I do, and they really looked at this, and I think Dan was the one who looked at making the changes in the Postgres extension temporal tables. So to do this, each live data table that needs versioning is given an additional column name now called the sys period, as noted there, and that holds the timestamp range value, identifying the start timestamp, the end timestamp, and a boundary condition of when the record is or was valid. So the name sys period is chosen to be consistent with the temporal table documentation. For each live data table, then there's also the corresponding history table to hold the historical data. They have the same structure as the live data tables, but without the same primary keys or unique constraints, and they are used for storing only historical versions of the data, which are not valid at the moment. For consistency, all history tables are given that hist underscore prefix, then the same name as the table being versioned. The trigger provided by the temporal tables extension is added to each live data table to be called before insert, update, or deleting transactions. And before any update or delete of transaction, the trigger inserts a copy of the existing row from the live data table into the history table with the timestamp range modified to show the current date as the upper bound of the validity interval. So then views are created for each table with history suffix, and that allows a user to query all the live and historical records in a given table or tables. And then let me just, a new limited access schema named Data Broker is created with views pointing to each with history view. And these views are defined to automatically limit the results to a certain timestamp. One of the things I didn't mention too, real quickly, is that this is an evolving data set. So there are, we may run a query on patients that have labs that are then updated because the lab results weren't in yet. So this is sometimes a constantly changing data repository. It doesn't change as, it really only changes around someone being in the hospital or right after a hospital visit, but nonetheless, it does change. So as you can see, then there are the ETL, the exchange, transform, and load incrementals that happen so that if there was an update, it can go into the history table. Regarding the other RDA working group data citation recommendations, as you can see, here's what we decided to do. Is we decided to, because of the query store timestamping or PID features did not exist in the identified data repository, so we needed a method of logging the queries that have been run by data brokers and making them uniquely identifiable. So we implemented a function named the data broker query tracking to serve really three purposes: to ensure the currently executing query has been logged, to return a date and time value to use in the querying data, and to return a pre-formatted citation set. So what's showing up on the screen, though, is the view that the data brokers can see. Excuse me. So that you can have the functions, the triggers, the query audit table. So let's walk through the data reproducibility workflow. And again, this is from the perspective that we really wanted the data brokers to be able to do this without having to ask a developer to pull data. So today, the data broker queries the data from the view. There is a log of the audit data, and then from the citation, that query PID is generated. What's really nice in the future is that using that query PID, the researcher can provide the query PID to the data broker, or let's be very practical about this, we also hold on to these PIDs in case the researcher doesn't have it. And then the data broker can rerun the query by executing the data broker rerun historical query function that was implemented within Postgres. The function takes two arguments, a desired name for an output, and the query PID provided by the researcher, or the one that we kept in our logs. The final function is, is to determine whether the data has even changed. Okay, and it takes the same two arguments as the other one, and basically will run the identified query twice, once as of the current date and time, and again as of the original query date. So, and it'll then just compare the results of both queries, looking for any differences, and then a Boolean true or false is provided to the data broker. So if the result is true, a temporary table with the data differences is also created. And in all cases, the data broker need only use any existing database query and administration tool that can run these. So this is just a nice feature. If the data hasn't changed, you don't need to make certain other changes. And if the data have changed, it's very interesting to understand also what in the data has changed. So let's look at this implementation in practice, and give me just a second. Okay, so this is a little bit of a change, but this is what we're using to really convey what has been done by the implementation team, and really going over to how to present it to the data brokers. So as mentioned before, we instituted a Postgres extension called those temporal tables. Excuse me. They instantiate a table equivalent for each table for historical data. When the update is made in the RDC tables, the RDC is our identified data repository. The extension logs the time and the old version of the row in the historical table. So the history tables only contain redacted data. This would be the data that is not identified. We've also instituted a series of views that will be much more useful to the data brokers. The views have both the live data and all of the historical data. And that's what the data brokers use to fetch historical data from the RDC. Excuse me. So as shown here, currently all the RDC data is in the RDC schema. The plan is for data brokers to have access to the schema that will automatically log queries that are run on it. So here's just a quick query on the sample data that's in a data broker encounter table. So because Brian, who put this together, wasn't sure what, we're never sure whether we've used fake data or real data, so we just redact it. So bear with us on the information. I think you can get the idea that this has been scrubbed a little bit. So, excuse me. So here's the data broker schema. You're just selecting from the data broker encounter, and then here's, as they like to say, the real magic from the data broker schema. You can pull up any query run in the schema, and here Brian's asked for all the data on his username with the date that he ran the query, just as you saw in the last slide. And then you can see on the right there's a formal citation column. It doesn't yet, but the plan is for it to automatically populate the formal data citation, so a researcher could include that in the paper. So we're still working on some of this. And then, let's see, one more thing in practice right here, and this is what we were just talking about. This is, has the data changed? So when thinking of rerunning a query, the data broker can just copy and paste in the stuff, and off you go. So if you'll notice, the arguments up there is previous, which is what the name is, and then 124, which is, if you go back here, it's the query ID. If you see it in the second column, is 124. So that's now put as an argument. Excuse me. So this is that handy function of has my data changed, and you get a Boolean response of false, the data hasn't changed. So note also that Postgres will calculate intervals and ages on the fly based on a system time. So if you've used an age function for your original query, your results here will be messed up. So we're trying to, we're also looking at that right now. So for example, one of the things is we want to know how old a patient is at the time of the query. Obviously, if you rerun the query and you don't control for the dates, that gets a little bit messed up. Excuse me. So that's the how we've done it. This is some more example of from the, we just use the commands. As you can see, they have to be run together, and the first creates a cursor and the second displays it, and they have to be highlighted and run at once, but it's really not that, that challenging. And then, as we mentioned, the citations for the query, you want to click on the message tab in the output, and there is the info note raised that it will contain the information necessary to cite the data set you've just generated. So what's really nice is the data brokers then give this the data to the researchers. They can then give the citation. And one of the things that we've heard from researchers and why they don't cite us is because it's very difficult and they're not sure. So we're trying to make that easier for research, and then of course that makes the research more reproducible if someone were to come back and ask for this. One thing I'd like to note on that is a lot of people start to question the reproducibility in the, you know, how many people from other institutions are going to come back and ask us and try to get a hold of our data. Typically they're going to want to reproduce these types of queries on their own data because for privacy reasons it's rather difficult to do it on other people's data. One of the things that we see and we know happens though is the need to be able to go back and find the same data when people transfer in and out of a lab. So when a new medical resident or fellow comes on and the past one has left, the researcher wants to continue the research, and this is a method to be able to more easily continue. So as future developments, we're looking at how to share the query PID with researchers in a more automated way, resolve the query PIDs to a landing page to make it easier for us, and then implement research reproducibility requirements in other systems as possible. If you recall from 20 minutes ago in the other systems that we have, we'd like to make sure that we can implement these suggestions in other ones. So just to talk a little bit through the outcomes and support, we implemented the working group recommendations, obviously not all 14, but the ones that we felt were the most easily to obtain and to make progress the quickest. We've engaged other adoptees who are also working with us on this. We've presented this both at RDA and others. We are sharing our code as we can with the community. And one of the interesting things I did on this was just what is our return on the investment of this grant? So conservatively speaking, it takes about 20 hours to complete one study, which if we were to not take into consideration that we do get subsidies for this, meaning we have government grants that help us not charge as much to our researchers, cost about $150 an hour to work for each data broker to work on this study, which makes it about $3,000 per study. So for the MacArthur grant and the money that they gave us, if we were to need to replicate 14 studies, it basically will have paid for itself. And in the time of getting the grant and implementing this, we have already had one request of replicating a need to replicate a study. Unfortunately, we hadn't implemented this So we've noted how long it's taken, which is almost 20 hours again to replicate a study. So we're really trying to reduce that and also, save on some costs. Of course, all of this is done by funding. I want to make sure that the MacArthur Foundation, our institution, and our cancer center are noted. And then this is obviously done by a team. There's the people on the right, the Research Data Alliance worked on this with the RDA collaborators down at the bottom, Andi and Stefan. We have another supplement working on reproducibility, and that's what's over on the left. And then there are some resources for you. Our repository, the slides can be found. I think Andy's going to share these. And then what we're also going to do is we're going to add the paper that we have has been accepted to the American Medical Informatics Association Joint Summits, which will be presented in March in San Francisco on this work. So I know that that's really only 35 minutes, but I think that I've gone through it, and now we can move to questions.
That's brilliant, Leslie. Thank you very much. If you've got any questions, you can either type them into the questions window and I'll read them out, or you raise your hand and I'll try to unmute you if I see you coming up in the attendee list. So those would be the two ways to start the discussion. While people are coming up with questions, Leslie, I was interested, like, what were the most difficult challenges that you found when you were trying to implement the solution? So I was actually we're delighted to hear about this age issue, because that's something we didn't consider at all. Kind of SQL type queries that might cause problems because they're relative to time. So that's definitely an interesting observation that we hadn't thought of before. And any other issues that were particularly challenging or that caused problems, or?
That's a good question, and I don't know if Snehal can be unmuted, because she could speak to they get into the nitty-gritty of things, and I get to see once they've figured these things out. So age is any sort of temporality is always a challenge when dealing with the data. Excuse me. But other than that, Snehal, I don't know if you can speak now.
I can't unmute her somehow. She's one of the few who seem to have called in via a phone line. So unless she adds her PIN.
Okay.
Snehal, sorry about that.
So I think what I can do is I can follow up to find out if there were other things besides that. But again, that is that is always a huge problem. Because so to walk just.
Can you hear me?
Yes.
This is Connie. This is Connie from WashU. I call for my cell phone, so maybe I can talk this way. But what I wanted to add, I'm sorry, I interrupted you, real quickly about the age. I think in Postgres, maybe in other SQL dialects, you could probably specify specifically what date you're comparing the birth date to if you're looking for age. If you specify directly, like compare birth date to this specific date, and it could be the first time the data broker queries the system, they directly state it in their query, it will be preserved for the next time they rerun it. And that way, you could probably work around the age problem. Does that make sense?
Mm-hmm. Yeah, I've just seen in the questions box, then basically also provided or suggested a similar solution of providing the date instead of providing the now date as the target date, to give a fixed date as the maximum. And I guess that's what you finally implemented, wasn't it?
That is what I understand was implemented. Connie, do you want to speak to that?
I'm not sure what we end up doing as far as implementation, but I'm pretty sure it can work.
I guess it can all be made work. I guess the important thing is to notice it when you launch a system, and you have to think of all the possible queries that people might ask, some of which might take relative dates and things like that into account. So I guess that's the challenge of knowing what people will do.
Well, and and that becomes very important in our system because it's not, I mean, age is the example that we're using, but it's very common that people want time before or after an event occurs. So, for example, if somebody has a myocardial infarction, a heart attack, they want to know within 30 days prior to it or 30 days after if there's information that they had some other event occur. So, for instance, did they have a stroke occur afterwards? So that temporality becomes very important, that relative time.
Okay. Are there any other questions by anybody on the attendee list? Sorry, I have to start scrolling now through the attendee list because it's so long that I can't see all of them on the screen at once.
That's fantastic.
Which is good. We had 55 people attending at a certain point in time. There's a question here. I don't see any new questions coming in at the moment. So that's just a quick question. You said because you provided the source code in the Git repositories. What is in there? Because I guess it's tightly integrated with the system that you're running. Is this now to a vanilla I2B2 system or?
No, I actually, we have our research reproducibility repository, but some of the code has not been shared yet. I want to put that out there. So as we move forward, people can see what we've done and what we're doing. So it really is a location at this point. What we had planned to do was, as we implement changes into I2B2, we can share that with the I2B2 code base and those changes, but because we haven't gotten to I2B2 yet, those changes have not been made.
Okay. Great. Any further questions?
Hi Leslie, this is Snehal here, and I just wanted to add for the I2B2 part. So we have implemented these changes on the database level, but not yet in the I2B2 application. So we could support research data reproducibility through the data broker mechanism, but not directly through the application UI.
Okay. But the data broker seems to be the most powerful interface anyway in your setting, isn't it? This is where most of the access is channeled through.
Right now, yes, that is the case. At other institutions who've implemented I2B2, it seems that their data brokers are the ones that use it as well, more than the individual researchers. So yes.
Okay. Well, in this case, I would say thank you very much for the presentation. If there is no further questions, I'll close this webinar, and I'll basically just to announce the next webinar. We'll have one already scheduled for Monday, 13th of February, at the same time. And James Duncan will present their implementation of the recommendations at the Vermont Monitoring Cooperative from the University of Vermont in Burlington. So that's the next story we're going to hear. And I guess the goal would be to collect all the lessons learned from the various pilots and basically pull them together in a whatever consolidated report and then discuss them also maybe at the next plenary session. If you've got any further questions, we'll try to make the recording available after the webinar. And I guess it's fine if people contact you via email if they've got more specific and more detailed questions, because that's something I noticed from earlier webinars, that there is very little discussion during such an online session, and then people get at you with email. So
yep, that should be fine.
Okay, in this case, thank you very much, everybody. Thank you for joining.
Thank you, Andy, for having us.
That was brilliant. Thank you so much.